Welcome to True Projects. In this video, we are going to explain about a project titled Efficient Human Activity Recognition Solving the Confusing Activities via Deep Ensemble Learning. The project focuses on human activity recognition, which involves identifying the actions performed by the individual based on the observations of the subject. It finds it in the various areas such as indoor pedestrian tracking, healthcare, and smart cities. Currently, these methods can be broadly categorized into two groups: vision-based and sensor-based. Vision-based approach rely on high frame rate video device to analyze and interpret the visual data, while the sensor methods utilize the smartphone sensor to capture and analyze the pervasive data related to the human activities. The objective is to introduce a framework for human activity recognition that utilizes the CNN with two convolution layers. The framework leverages data from accelerometer, gyroscope, and the magnetometer of smartphone to address the challenges associated with the human activity recognition. These challenges include variations in motion mode among the individuals, limited training data availability complex and the diverse human activities, and potential confusion between highly similar activities. Additionally, the project proposes a novel ensemble model of CNN to further enhance the accuracy of the activity identification. The effectiveness of the proposed model is evaluated using a dataset comprising of sensory samples collected from the various subjects. The result demonstrates that the accuracy of the proposed model is above 95%, indicating its efficacy in accurately recognizing the human activities. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements are Python IDE with version of 3.7. These are the modules that are developed to build this project. The first one is upload HAR accelerometer and gyroscope dataset. Using this module, we will upload the dataset to the application. And the second module is pre-process the dataset. Using this module, the uploaded data often contain the missing and non-numeric data. By this module, we are applying the non-numeric data conversion into the numeric format by applying of some techniques and normalization. The third module is train the CNN7 and CNN2 ensemble algorithm. In this module, the pre-processed data will get trained with CNN7 and CNN2 algorithms and then perform the prediction on the test data and calculate the prediction accuracy and the confusion matrix. And the fourth module is train the XGBoost algorithm. In this module, the processed data will get trained with XGBoost algorithm and then perform the prediction on the test data and calculate the prediction accuracy and confusion matrix. And the fifth module is train the random forest algorithm. In this module, the processed data will be trained with random forest algorithm and then perform the prediction on the test data and calculate the prediction accuracy and confusion matrix. And the final sixth module is of comparison graph. Using this module, we will plot the comparison graph between all the algorithms and the metrics we used in those algorithms. And the seventh module is ensemble accuracy graph. In this module, we will plot the ensemble CNN7 and CNN2 training accuracy and loss graph. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first folder contains of compiled Python file and the dataset folder consisting of the HAR dataset and the test HAR dataset. And the model folder consisting of H5 files. These files contain the algorithm information and these files can be loaded into the project code during the runtime to utilize the trainer model for various tasks. such as making predictions on new data or performing the specific operations. And the custom button main and test are the Python files, and this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload HAR, Accelerometer and Gyroscope dataset. Here, it redirected to the dataset folder consisting of these two datasets, and we need to select the HAR dataset and click on Open button. By this, we get an activity graph where the x-axis represents of the activities and the y-axis represents of the count of the activities performed by the human, and close this graph. Here we can see that of the algorithm is loaded and of consisting of both numeric and non-numeric data. First, we need to convert the non-numeric data into the numeric format. For this, we need to pre-process the dataset. Then click on Pre-process dataset button. By this, the dataset is pre-processed and the non-numeric data is converted into the numeric format, and total records found in the dataset is of 7352. And click on Train CNN7 and CNN2 Ensemble algorithm button. By this, the CNN algorithm is generated on the pre-processed dataset. Here, in this confusion matrix, x-axis represents the predicted class and the y-axis represents the original dataset class. And we can see all the classes in the both predicted and original are correctly predicted. And all the records, only the two classes are wrongly predicted. And the CNN gives an accuracy of test data for 99% and precision of 99, recall of 99 and F-score of 99%, and trying the XGBoost algorithm button. By this, the XGBoost model is generated on the pre-processed dataset and giving an accuracy of 97%, precision of 97%, recall of 97% and F-score of 97%. And click on Train Random Forest Algorithm button. By this, the random forest algorithm model is generated on the pre-processed dataset with giving an accuracy of 92, precision of 92, recall of 92 and F-score of 92%. And then click on Comparison Graph button. By this, we get an bar graph where x-axis represents the algorithm names and the y-axis represents the values, where each bar represents each metric. Blue bar represents accuracy, orange bar represents of F1 score, green bar represents of precision, and the red bar represents of recall. And close this graph and click on Ensemble Accuracy Graph button. By this, we get an CNN Ensemble Accuracy Graph where x-axis represents the iterations or epochs and the y-axis represents the accuracy and loss. Here the green line represents of accuracy and the y line represents of loss. We can see that increasing of epoch, the accuracy got increased, and the increasing of epochs, the loss got decreased. And close this graph and click on Predict HAR from the Test Data button. By this, it redirected to the dataset folder and select the Test HAR dataset and click on Open button. By this, we get a screen of all the information of the test record, and after the arrow mark, we can predict as of recognized as sitting. And this way, we can detect the efficient human activity by using these models. The project proposed a human activity recognition framework based on the convolution neural network with two convolution layers using the smartphone-based accelerometer, gyroscope, and magnetometer. The proposed framework aims to solve the challenges of human activity recognition, such as different motion modes for different individuals, limited training data, complex and arbitrary human activities, and confusion between the highly similar activities. The project also presents a novel ensemble model of CNN to further improve the identification accuracy. The proposed model have been evaluated using various samples from the total of 100 subjects, and the results have shown that the classification accuracy and the proposed model is getting of 96%, which proves the effectiveness of the proposed model.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.